Now in this part, I can show you some problems. So for example, the force harmonic vibration आपको बताया. So these are the problems now regarding with the forced vibrations. The steel frame that is shown in the figure sports a rotating machine. This is a steel frame. It sports a rotating machine, and that exert horizontal force Ft equal to the F sin omega t. So force frequency क्या है? 5.3 ohm, and 200 is the peak of the force. That is the amplitude of the force. Assuming 5% of the critical damping, determine the steady state amplitude of the vibration and the maximum dynamic stress in the column. Assume the girder rigid. So in this problem where the force is given, problem was same like we did in the free vibration, but here with the force. So what will be changed? The stiffness is same. 3E and 2 columns are present. So that's why the stiffness is same. The 2 columns are present and the stiffness is determined. Now the damping ratio is 0.05 and static displacement you know is P naught over K. From where we pick the P naught? This is the given value of the force, P 200. So F naught over K. K is computed. So we get the static displacement. Now omega is K over M. Stiffness nikali. You get the omega, and the frequency ratio यहाँ पे this is denoted by R in the book, but beta in the class lecture. Frequency ratio. So beta is equal to omega bar machine frequency divided by the system frame frequency. So this is omega is computed here, and the 5.3 was given for this frequency of the force. Applied loading तो ये beta है और R है, and the question is that determine the steady state amplitude factor, the ratio of the static displacement to that one. You can, this expression is 1 minus beta square, ये जो हमने पढ़ा भी है. So that is basically used to the ratio of the static displacement to the steady state amplitude आपने निकालना है AD. So AD is basically here the value used is U, and in the lectures it is used as AD. So U has, this is the steady state amplitude for the this system. Now you have the displacement, the amplitude, the maximum one, and you can determine the shear force. कैसे? You know that for this case, this frame, for one column, the shear force will be 3IU over L cube. The maximum shear force for one column is 3IU over L cube, and the maximum bending moment will be the shear into the length. उससे bending moment आ जाएगा, and then the maximum stress will be My over I. Bending moment निकाल लिए, and after that the stress in the column you know is My over I. So you can compute the stress. I over C, the moment of inertia, or C, these are given. ये जो steel frame है, you can see the value of this, the moment of inertia and C. So by putting the values, you can determine the maximum stress in the frame. ये इसका problem है with force. This problem is for computing the damping. I told you कि अगर आपके पास पीक भी हो रेजोनेंस पे 1/2 हाइट पर आप निकाल लें, 1/2 हाइट पर you get the beta A and beta B and take the difference of that, दोनों का difference लें divided, or you can get the zeta value. So this formula was also proved today in the lectures, that if you have the peak displacement, take at of 1/2 under root of that, you get this value at 1/2 under root this value, that how much is this is equal to 1 by 2 under root. और graph से from the graph see these two values f1 and f2. Graph से from the graph you can see f1 and f2, this value and second value, and from that you can determine the damping ratio. Damping ratio can be computed. Another problem where a machine is weighted, weight this is mounted on a simple supported beam as shown in the figure. A piston that moves up and down in the machine produces a harmonic force of 7,000 pounds at a frequency, force frequency. It is denoted by omega bar, sometime it is denoted by ohm in the lecture. Omega, this omega. Neglecting the weight of the beam and assuming 10% damping, determine the amplitude of the motion, force transmitted to the beam support, TR, the corresponding phase angle. So this system is left hand side. How much force is transmitted to the K is this one, the damping is also there. So damped harmonic motion का case. Please supported beam is 48 Ti over L. The K over M of the machine to the beam is 100, 60, 100, so 0.6, and static difference F naught over K. F naught क्या था? 1,000, 7,000 pound. The load of the machine divided by this, and it gives you the amplitude of the motion. That formula is UST over 1 minus R square. ये हमने पढ़ा है. So this amplitude is determined and phase angle is also computed. Tangent inverse 2 R 2 beta zeta or 1 minus R square. So you can determine the phase angle and now how much is transmitted to the ground. So transmissibility formula, that what was the amplitude AT and what was the force which was applied and what was the force that was transmitted to that. So the formula I told you for the transmissibility. So by putting the value 1.54, it means that the force, that amplitude force that produces is 1.5 times higher the applied loading. Foundation पे आप कितना transfer हुआ sports पर? You multiply this factor with the applied load. So it means that the TR, and you multiply this much force is transferred to the foundations. The corresponding phase angle can be computed to zeta beta cube divided by 1 minus beta square plus 2 r zeta whole square. This is the corresponding phase angle for this case. So this is the transmissibility. So please read the this chapter. I will show you at the end above from the book that all these things are further clarified. This is also one problem from the problem from the book, that an air conditioning unit is bolted at the middle of the two parallel beams. The clear span of the beam is 8 feet and the second moment of area of the beam is this one. The motor in the unit runs at 300 RPM and produces an unbalanced force of 60 pounds at this speed. Neglect the weight of the beams and assume 1% viscous damping in the system. Determine the amplitude of the steady state deflection and steady state acceleration of the beams at their midpoints, which results from the unbalanced force. So due to the air conditioning and the movement of the cooling unit, we have to determine the effect in the beam. All the parameters and the weight of the unit are given. This problem is from the A.K. Chopra book. So W is given, E is given, I, L, zeta is given, P naught, the force. Can determine the omega. How? Because omega was the revolution अगर given हो मोटर के 300 revolution per minute. So revolution से हम निकाल लेते हैं 300 by 60 into 2 pi. This give the omega. Revolution per minute है ना, तो we divide it to second के लिए 300 by 60 into 2 pi. So this is the omega in radian per second. Stiffness of the two beams can be computed by 2 into 48 EI over L cube. And natural frequency of the system जो है वो ये है. ये omega जो है that यहाँ पे इस book में machine frequency है. And this is the natural frequency of the system. Now you have the omega value, omega n. यहाँ पे वो RD से denote करता है U को इस book में. So displacement response factor is computed. This one 1 over 1 minus omega over omega n whole square plus 2 zeta omega n omega square, and omega over omega n ये beta है, the ratio of the two frequencies. You can determine the ratio of the two frequencies by taking the frequency of the machine over the system and RD में इसको put कर दें and get the RD value. Now the displacement जो है P जो displacement है, that is denoted by the U in the previous example. So here U naught, UST से multiply कर दें displacement response factor को, तो you get the, this is the value of the displacement, peak displacement, acceleration amplitude. ये acceleration के साथ हम इसको कर सकते हैं. We can determine the acceleration by multiplying by the U naught into omega square. This is the acceleration amplitude. This is the relation between the displacement response factor and the acceleration response factor. This we can compute the required parameter for this problem. There are some other problems also, try to see that, and practice that. If you feel any confusion, then you can send me the message in the team. But most of the problem, just this problem where the eccentric mass vibrator is there. This is a problem in the Mario Paz book example, where a simple beam sports at its center. Machine का weight है, the beam is made of the two standard beam का detail दी गई है, and the motor run at this, and motor is out of balance. Motor out of balance है to the extent of this 40 pound at an eccentricity of this one. What will be the amplitude of the steady state response? I told you about the eccentric mass vibration, that when the eccentric mass vibration is there, the one case today, this one जहाँ पे जो मैं बता रहा था, ये वाला case है. And when the eccentric mass vibration is present, तो eccentricity होती है और mass और ये आपको response आता है. So this is the problem, and this can be represented by free body diagram. इसकी आप इस तरह बना सकते हैं कि आपके पास एक तो displacement आएगा इस system का, and there is also the eccentricity of the machine also, क्योंकि machine का mass E naught पे है. So total displacement क्या होगा? u plus E naught of sin omega t. And you can represent this system, the eccentric mass जो है उसका आपका फोर्स बनेगी ma, उसका अपना एक्सेलरेशन होगा, और जो आपका अपना मशीन के सेंट्राइड पे शिफ्ट होगा m माइनस m स्लैश इंटू यू नॉट, क्योंकि एक हमारे पास बीम है, तो ये इसका मैस है बेसिकली, एक सिस्टम का जो आपके मैस है. So now how you get the k value, same procedure है, but it's k, you get the omega value of the system की निकाली आपने frequency, and the omega value ये आपकी force, यानी कि you have the machine which is a 300 rpm, उसको convert किया, determine the force frequency and frequency ratio निकाल ली, which is beta r omega bar over omega. Now you know that in this figure, I told you that the total displacement will be the u, the system displacement, plus the machinery displacement. Why? Because the m be the total mass of the motor and m the unbalanced rotating mass, the u is the vertical displacement, so it will be sum of that. So equation of the motion is obtained by summing the force along the vertical direction in the free body diagram, where the inertial forces of both the non-rotating mass and of the eccentric mass are also shown. So you can sum these, basically the total equation of motion will be the m minus m prime u. This is for the downward force, this is for the eccentric mass, and this is the damping, and this is the stiffness. So putting the values of m prime, the weight of the machinery because of the eccentricity, ये of m prime होगा, m is the mass of the system. And first we put down all the values that basically are u naught जैसे है u1 dot. This is the difference between the acceleration of the system, and this is the value that is obtained by the from the machine. And then simplifying it, keeping the same term on one side, and eccentric mass की जो force है, that is m prime E naught omega square. It is equal to this one. So we have all the values. This is the eccentric mass force, and from that now we have all the parameters, and the u will be written. U is basically f naught over k divided by this formula, 1 minus r square plus 2 r into zeta square. So u can be the amplitude of this system can be determined. This was basically unknown, the amplitude, and f naught in this case, as in the lecture I said, is not of eccentric mass force will be me omega square. The force magnitude is determined from this problem, and the remaining try working on all the problem. And we discussed today about the
सर आवाज नहीं आ रही. सर आपकी आवाज नहीं आ रही.